Hi everyone, I'm Weizhou from the Interactive Media Lab Dresden. I'm excited to present our work, Beyond Links, Exploring Visual Representation of the Multi-View Relation in Mixed Reality. This is a drawing work with Rzayev, Benjamin Russig, Sivanon Apple, Marc Satkowski, Stefan Gumhold, and Raimund Dachselt. Multi-view interfaces are common in 2D display environments. They bring together two or more different but related views of the same underlying entity, such as a prime dataset, but also a process or a problem space. Because those views are different in representation, perspective, or level of detail, they allow users to explore complementary aspects side by side in a coordinated workspace. Mixed reality is especially promising for this kind of the workspace, since it offers much more space for arranging views and allows them to be placed flexibly in 3D environments rather than being limited in a single screen. Given this new affordance, a key design challenge arises. How do we communicate relations between views in mixed reality? To address this, we explore visual representation of the multi-view relation in mixed reality. Let me first briefly position our paper in relation to prior research. Previous 2D multi-view research has already shown the value of the coordinate views for analysis and sense-making and has provided substantial guidance for arranging and coordinating them. More recently, researchers have extended the multi-view concept to immersive environments, showing both the potential of the distributed view in 3D space and the challenges of the occlusion, navigations, and coordination. Reader works have also examined the techniques such as linkage, coordination, and proximity. However, mixed reality still lack of a systematic understanding of how to represent such relations beyond simple linking in immersive settings. To address this gap, we explored the design of the associations in multi-view mixed reality environments. To clarify our terminology, we define a view as a self-contained, spatial bounded region that organizes visual elements to represent data. A relation is a semantic or contextual connection between two or more views, and it can be driven by content, task, or users. An association is an explicit representation of such relations, which help the user to understand how views are connected. Methodologically, we start from a prior 2D and 3D multi-view and cross-view visualization research using the snowball sampling and citation searches, and collect an initial set of the 98 papers. After applying our inclusion criteria, we arrived at final corpus of the 44 immersive multi-view papers. We then constructed an initial codebook of association techniques from 2D research and adapted it to immersive contexts. Lastly, two authors coded those corpus, refined the codebook iteratively, and used this bottom-up analysis to identify recurring strategy and derive the design space. We then reapply those schemes to the full corpus to confirm its coverage. Let me now move to our results. Our first contribution is 7 recurring association strategy and patterns that show how relations between views are commonly represented in immersive environments. Due to time, I will focus on 5 of them. The first one is a planar and a cylindrical uniform grid. This strategy arranges the views in a regular grid so that they can share the same footprint, alignment, and view style. Its main strength is comparison because its highly uniform layout makes the pattern across the view easy to identify. Examples including small multiplies for species distribution, pedestrian volume over time, or cereal sugar content. In immersive settings, the grid can also be wrapped around the user in a cylindrical form to improve the visibility. Another strategy is slideshow with the thumbnail. Here, one dominant primary view is combined with several smaller thumbnail views. The large view either provides an overview or highlights the current focus, while the thumbnail offers the supporting context or additional detail on demand. For example, a large flat map can be accompanied by several smaller maps, or a console view can show the band in the main map panel, while the thumbnail presents individuals. A third strategy is the stack and the ripple. This strategy uses the depth to represent the hierarchy, granular, or contextual relations. In a stack, views are layered along the depth to show different facets of the same location or subject. Example including the terrain layer on the maps, different depth in the bring imaging, or layered slide elements. In a repo, views are arranged in a concentric rings around the user. Within the inner ring contains the most important or frequently accessed views, and the outer ring providing weaker or more contextual information. Another interesting pattern is the temporary reading order. This strategy uses the reading direction, such as the left from left to right or from the top to bottom, to communicate the sequence. It is used for showing the chronology, workflow, or provenance, because the arrangement itself creates a visible storyline from the earlier to later states or from the source to results. For example, a chain of the view can represent a process or a sequence of the event or a branching deviation from one source into multiple outcomes. Finally, reference and anchor positions the virtual view relatively to the physical reference, such as the body, screen, object, or environment. The main idea is that the physical reference acts as the center of the gravity for organizing views. For example, views can be attached to the body for quick access, arranging around the physical objects, or placed near existing display to support familiar workflows. This is especially valuable in mixed reality because it connects the virtual view to the real-world landmarks and supporting saturated access. Together, those strategies show the relation between views in mixed reality can be communicated far beyond simple linking. Our second contribution is the design space for view association in mixed reality. We organize it into three components: view, relation, and association. For the sake of time, I will only briefly highlight some parts. The view component describes what the view are, including the modality, dimensionality, and the state. The relation component describes how views are semantically linked or distinguished independent from any particular visual form. It includes attributes such as the coordinality, granularity, spatiality, and temporality. The association component then explains how those relations are made visible in mixed reality. For example, view geometry concerns how relations become legible through the spatial layout, including the grouping cues such as the proximity, continuation, and overlap, as well as the separation cues such as anchoring and the space partition. Visual mark describe how relation can be graphically highlighted or traced through the explicit encodings, while the visual effect introduce animation that help guide attention. Together, those components describe what the view are, how they are related, and how those relations are made visible. To demonstrate the design space in practice, we built a lightweight Unity prototype for MetaQuest 3 and used it for develop 3 scenarios. Due to time, I will focus on 2 of them. The first scenario is the traffic monitoring. A large city map provides the overview where the CCTV feeds, ortho photos, and the vehicle camera screens offer local and dynamic detail. Associations are used to class the reader view around each intersection, connect them back to the map, and keep the prioritized vehicle feeds anchored close to the user for quick awareness. Another scenario is the criminal investigation storytelling, where documents, image, and the 3D evidence are arranging into a layered evidence board, links, grouping, and fading effect, helping make the narrative structure visible. A secondary view on the user from arms then guide the story step by step, highlight the relevant cues that fading less relevant ones into the background. To conclude, we investigate the associations and explicit visual representation of the relation between multiple views in mixed reality. We review both the 2D literature and the immersive approaches. From this, we identify 7 recurring association strategies and patterns, derive a design space, and demonstrate its use through a lightweight prototype and 3 envisioning scenarios. Looking ahead, we encourage future research on mixed reality specific strategy that better use the spatiality, for example, by combining multi-strategy and supporting navigation through the mobility and embodied interaction. We also saw strong potential in anchoring the view to the physical environment, which can make the mixed reality experience more saturated and better support familiar and context-rich tasks. Thank you for listening. For more detail, please refer to our paper and our project website.